जो टॉपिक है वो Bolzeno weierstrass theorem है. This is a very important theorem in real analysis. This is Bolzeno weierstrass theorem. We have two Bolzeno weierstrass theorem. First one is the theorem for sets, Bolzeno weierstrass theorem for sets, and second one is Bolzeno weierstrass theorem for sequence. तो आज का ये जो थ्योरम है Bolzeno weierstrass theorem है सेट के लिए. ब्रैकेट में यहाँ पे लिखना चाहता हूँ क्या ये सेट जो है ना वो सेट के लिए है. तो क्या बोलते हैं Bolzeno weierstrass थ्योरम हमें क्या कहते हैं? वो ऐसा कहते हैं कि if there is a infinite bounded set, so then the set have a limit point. Bolzeno weierstrass theorem states that every infinite bounded set has a limit point. Every infinite bounded set has a limit point. तो ये Bolzeno weierstrass है. That is, if S is a set which is S is infinite, and bounded, that means S have a lower bound and have a upper bound, then F is called bounded. So S is a set, infinite and bounded set, that means S is infinite and S has lower limit and upper limit. Okay, that means lower bound है, upper bound है, least upper bound है and greatest lower bound है, supremum and infimum है, ऐसा बात है. तो is bounded and bounded. Then if S is an infinite bounded set, then there exists psi such that is psi is a real number. There exists psi which is a real number. There exists psi जो है ना वो एक real number है such that psi is a limit point of S. Okay, psi is a limit point of S. Okay, so ये हमें दिखाना है. So we will prove this. थ्योरम जो है ना वो यहाँ से शुरू होता है एवरी से और यहाँ पे खत्म होता है. तो इसका प्रूफ let S is a infinite bounded set. That S is an infinite bounded set. Now since it is bounded set, S has a supremum and S has an infimum. Let S is an infinite bounded set and small m is least upper bound. That means small m is supremum. हम लिखते हैं small m is supremum. And small l is infimum. Okay, small l is infimum. Okay, ये बात सही है. Since it is bounded, so that there will be supremum, there will be infimum. ये दोनों होता है. इसके बाद now ऐसा एक सेट कंसीडर करते हैं. We will construct a set that is a new set. We will construct a new set. हम एक नया सेट बनाओगा such that let P be a set of real number, P be a set of real numbers डिफाइंड एज, कैसे डिफाइन किया गया है? डिफाइंड एज x belongs to P if and only if x exceeds, if and only if x exceeds a finite number of members of S. Okay. इसे डिफाइन किया गया है x is belongs to P if and only if x exceeds a finite number of members of S. That means x जो है ना वो P ऐसा एक सेट है, वहाँ पे जितना भी एलिमेंट है, जो भी एलिमेंट है वो सिर्फ और सिर्फ S के फाइनाइट नंबर्स ऑफ एलिमेंट से बड़ा है. मतलब ऐसा एक एलिमेंट A which is greater than infinite number of members of S, then A cannot belongs to P. Okay. सो ऐसे डिफाइन किया गया है सेट को. नाउ क्या करते हैं अभी? नंबर ऑफ मेंबर्स ऑफ एस. अभी क्या करते हैं? मेंबर्स ऑफ एस. नाउ ये क्या दिस सेट पी ये एम्प्टी है या फिर नॉन एम्प्टी सेट है? वी नो एम इज द okay, small l is the infimum of S. So small s is greater than, there does not exist any member in S which is greater than, which is less than small l. That means now small l belongs to P. Why? Because small l exceeds no members of S. Small l is the least upper bound, is the greatest lower bound. Okay, small l is the greatest lower bound. So ऐसा कोई भी एलिमेंट नहीं है जो स्मॉल l से छोटा है. So small l exceeds no members of S. So that means small l exceeds finite number of members of S. So small l belongs to P because small l does not exceed any member of S. Small l exceeds zero number of members of S. So small l exceeds finite numbers of members of S. That means so small l belongs to P. Hence P is non-empty. P is non-empty. That's it. P is non-empty. Now P is bounded above. Now for all x belongs to P, x is always less than or equal to नहीं हो सकता है. X is always less than or x is less than small m, which is the supremum of S. Small m is the supremum of S, right? So x P कैसा सेट है? P एक ऐसा सेट है जहाँ पर ऐसा x एग्जिस्ट करते हैं जो x सेट S के हर एक एलिमेंट से बड़ा नहीं हो सकता है. फाइनाइट नंबर्स ऑफ मेंबर से बड़ा हो सकता है लेकिन इनफाइनाइट नंबर्स ऑफ मेंबर से बड़ा नहीं हो सकता है. लाइक that means ये for all x belongs to P, x is always less than infinite numbers of members of S. X is always less than m. Since आप ऐसे समझिए अगर कोई x1 जो m से बड़ा है वो इनफाइनाइट नंबर्स ऑफ मेंबर्स ऑफ S से बड़ा होगा because m is greater than infinite numbers of members of S. So ऐसा एक x1 p में हो ही नहीं सकता है, ऐसा एक x p में हो ही नहीं सकता है जो m से बड़ा है. So x is always less than m. So p is bounded below, bounded below, bounded above, p is bounded above. And अगर ऐसा एक set of real number which is bounded above has a supremum. According to Archimedean property, according to Archimedean property, according to Archimedean property, what we have? According to Archimedean property, if every set of real number which is bounded above has a supremum. According to Archimedean property, P has a supremum. P has a supremum. Okay, ये तो है ही. P has a supremum. P का एक supremum होगा. P has a supremum. अभी देखिए, अगर P का एक supremum है, मैं अभी डायग्राम के लिए मैं आपको दिखाना चाहता हूँ. मान लो ये एक इनफाइनाइट बाउंडेड सेट है, ये सेट S है, दिस इज स्मॉल l, दिस इज स्मॉल m, और ये जो सेट है, दिस इज द सेट, दिस इज द सेट S. ये क्या है? S है. अभी P ऐसा लिया है, P इज फ्रॉम दिस, ये तो हो सकता है, ये यहाँ से और कहाँ तक जाएगा, मान लीजिए यहाँ तक जाएगा. अगर दिस इज द सेट P, okay, this is the set P, okay, if this is the set P, then there are infinite numbers of members from here to here, from here to here there exists finite numbers of members of S. अभी देखिए, S is infinite, तो S के infinite numbers कहाँ पर हो सकता है? ये outside of P, यहाँ से यहाँ तक, यहाँ से लेकर के यहाँ तक, यहाँ पे infinite होना पड़ेगा, right? Since S is infinite, तो infinite numbers of members यहाँ पे होना पड़ेगा. यहाँ पे ये क्या होगा? यहाँ से यहाँ तक, यहाँ से यहाँ तक, यहाँ से यहाँ तक, ये सब finite होना पड़ेगा, finite. यहाँ पे क्या होना पड़ेगा? finite होना पड़ेगा. ओके, यहाँ पे finite. तो अभी P has a supremum. That means यहाँ पे मान लो ये है supremum, P का supremum, वो m dash. Okay. So P has a supremum, and let the supremum of P is small m dash. So small m dash कहाँ पे लिया? ये है small m dash, यहाँ पे राइट, ये small m dash है. मैं कलर चेंज कर लेती हूँ. ये है, मान लीजिए ये small m dash है. ओके, ये वाला है, it is. So S has a supremum, S का ये supremum है. So since P has a supremum, so P का supremum तो है ना वो small m dash है, ये supremum है. तो अगर ये supremum है, small m dash is the supremum. Okay. Now so we will have to show what? There is a ऐसा एक रियल नंबर साई है जो S सेट का क्या है? लिमिट पॉइंट है. बिकॉज S is infinite bounded set, so S should have a limit point. So small m dash is the supremum of P. Small m dash is the supremum of P. अभी क्या होता है? Now for any epsilon greater than 0, small m dash minus epsilon, ये क्या होता है? Small m dash minus epsilon, ये जो है, this is not a upper bound of P. p की अपर बाउंड नहीं हो सकता है स्मॉल m dash माइनस एप्सिलॉन इज नॉट ए अपर बाउंड ऑफ p small m dash minus epsilon, but small m dash plus epsilon is the upper bound of p, and small m dash minus epsilon is not a upper bound of p. For any epsilon greater than 0, m dash minus epsilon does not, m dash minus epsilon cannot be a upper bound. Cannot be a upper. Cannot be a upper bound. Cannot be a upper bound. Cannot be a upper bound of m dash minus epsilon cannot be a upper bound of p. So there exists a member, let eta, so there exists eta, okay, eta, there exists eta in p, so there exists eta in p, because such that there exists eta in p such that eta is greater than m dash minus epsilon, okay, sorry, m dash minus epsilon, greater m dash minus epsilon, m dash minus epsilon, okay, eta is greater than m dash minus epsilon, eta is in p such that n dash is greater than m dash minus epsilon. So eta is in p such that n eta is greater than m dash minus p. Why? ये भी देखिए bounded of, so upper cannot be upper bound of p, so there exists eta in p such that eta is greater than upper bound नहीं है, that means a side number to p में होना चाहिए जो वो जो upper bound है उससे बड़ा है, right? So eta will be greater than m dash minus p. ये बात है. Now अभी क्या होता है? Since that means, so now eta exceeds, since eta belongs to p, eta exceeds finite numbers of, eta exceeds finite number of members of, eta exists finite numbers of members of p, numbers of x, okay, since eta exists finite numbers of n, so m dash minus epsilon which is less than eta, okay, this exceeds, that means m dash minus epsilon exceeds, ये ब्रैकेट में लिखूंगा m dash minus epsilon which is ब्रैकेट में लिखूंगा less than eta, since less than eta, so m dash minus epsilon is less than eta, so exceeds finite number of members of finite numbers of members of s, finite numbers of members of x, so finite numbers of members of s, x is finite numbers of members of s, that okay, m dash minus epsilon exceeds finite numbers of epsilon. Now m dash is the upper bound of p, so since m dash is the upper bound of p, so m dash plus epsilon, this is not belongs to, this is okay, m dash plus epsilon, since m dash is the upper bound of p, that means m dash plus epsilon cannot belongs to p, cannot belongs to p. अगर p में एग्जिस्ट नहीं हो सकता है, ये m dash plus epsilon अगर p में एग्जिस्ट नहीं हो सकता है, that means m dash plus epsilon, why it cannot belongs to p, because it must be exists infinite numbers of members of s, so it is not belongs to, okay, cannot, m dash plus epsilon cannot belongs to p, because okay, cannot belongs to p, cannot belongs to p because m dash is the upper bound, because m dash is least upper bound, right? Least upper bound. M dash is least upper bound of p. Okay, that means if because so since m dash cannot belongs to p, hence m dash plus epsilon must exceed infinite number of members of X. Okay. So m dash minus epsilon, comma m dash plus epsilon. M dash minus epsilon exceeds finite numbers of members of S. M dash plus epsilon exceeds infinite numbers of members of S. That means क्या बात है? M dash minus epsilon, M dash plus epsilon, ये जो open interval create होगा. So this contain infinite number of members of S, right? So since m dash minus epsilon, m dash plus epsilon contain infinite numbers of members of S, hence m dash is a limit point of S. That and S is a infinite bounded set, and F, so we have finally obtained that S has a limit point which is small m dash. So every infinite bounded set has a limit point. Hence the theorem. Hence every infinite bounded set has a limit point. Okay, so this is proved. Okay, हो चुका है. थैंक यू. वीडियो को कंप्लीट देखने के लिए थैंक यू. अगर कुछ समझ में नहीं आया है तो मुझे कमेंट कीजिएगा, मैं फिर से इसके ऊपर वीडियो बनाऊंगा.